OSI model, a journey through the network.
The OSI, Open Systems Interconnection Model, is a conceptual framework used to understand and standardize the functions of a network or telecommunications system. It is divided into 7 layers. The OSI, Open Systems Interconnection Model, consists of 7 layers, each with distinct functions that work together to enable network communication. Here's a brief overview of each layer. 1. Physical Layer 2. Data Link Layer 3. Network Layer 4. Transport Layer 5. Session Layer 6. Presentation Layer 7. Application Layer. Each layer interacts with the layers directly above and below it, ensuring a modular and manageable approach to network communication. The end-to-end communication model focuses on the process of data transmission from one end of a network to the other. It highlights the path and interactions between the source and destination systems, encompassing all layers of the OSI model. Here's a simplified overview of how end-to-end communication works in the OSI model. The OSI, Open Systems Interconnection Model, is a conceptual framework used to understand and standardize the functions of a network system. It is divided into 7 layers, each serving a specific purpose in the communication process. Here's a brief overview of each layer and its functions. Physical layer deals with the physical connection between devices, including cables, switches, and the electrical signals used for transmission. It is responsible for transmitting raw bit streams over a physical medium. Data link layer ensures reliable communication between 2 directly connected nodes. It handles error detection and correction, as well as data framing and addressing. Network layer manages routing and forwarding of packets across network boundaries. It is responsible for logical addressing and determining the best path for data to travel from source to destination. Transport layer provides end-to-end communication services for applications. It ensures complete data transfer through error recovery, flow control, and data segmentation. Session layer manages sessions or connections between applications. It handles the establishment, maintenance, and termination of communication sessions. Presentation layer translates data between the application layer and the network. It is responsible for data encoding, encryption, and compression to ensure that data is presented in a readable format. Application layer provides network services directly to end-user applications. It handles high-level protocols and user interfaces.
In the context of the OSI, Open Systems Interconnection Model, the term data directory isn't a standard term used. However, if you are referring to how data is managed or structured within the OSI model's framework, it relates to the concept of data handling and organization as data moves through the layers. Data at each layer. Physical layer transmits raw bits over a physical medium without organizing them into any specific structure. Data link layer organizes bits into frames, adding headers and trailers for error detection and addressing. Network layer encapsulates frames into packets and adds network addressing, e.g., IP addresses, to route the packets. Transport layer segments and reassembles data into segments or datagrams, ensuring end-to-end communication and error recovery. Session layer manages sessions or connections between applications, maintaining the state and sequence of communication. Presentation layer translates, encrypts, or compresses data into a format suitable for the application layer. Application layer handles the data in its final form, interacting with software applications and user interfaces. Data units. Application layer, data. Presentation layer, data. Session layer, data. Transport layer, segments, TCP or datagrams, UDP. Network layer, packets data. Link layer, frames. Physical layer, bits. The OSI model does not have a data directory per se, but each layer of the OSI model handles data in its specific format or structure, encapsulating it with necessary control information as it moves through the layers.
The OSI, Open Systems Interconnection, Model provides a conceptual framework for understanding network communication. Each layer of the OSI model has specific protocols associated with it to perform its functions. Here's a brief overview of the protocols typically associated with each layer. Layer 1 Physical Layer. Protocols Ethernet, USB, DSL, fiber optic, and other hardware-based standards. Layer 2 Data Link Layer. Protocols Ethernet, Wi-Fi, Bluetooth, PPP, HDLC. Layer 3 Network Layer. Protocols IP, ICMP, RIP, OSPF, BGP. Layer 4 Transport Layer. Protocols TCP, UDP, SCTP. Layer 5 Session Layer. Protocols NetBIOS, RPC, PPTP.
Layer 6 Presentation Layer. Protocols SSL/TLS, J, PEG, MPEG. Layer 7 Application Layer. Protocols HTTP, FTP, SMTP, DNS, IMAP. Each protocol operates within its respective OSI layer and contributes to the overall process of network communication, ensuring that data is correctly transmitted, routed, and received across networks. OSI devices. Layer 1 Physical Layer. Network cables. Network interface cards. Hubs. Repeaters. Modems. Layer 2 Data Link Layer. Switches. Bridges. Access points. Network interface cards. Layer 3 Network Layer. Routers. Layer 3 Switches. Multi-layer switches. Layer 4 Transport Layer. Firewalls. Load balancers. Layer 5 Session Layer. Session border controllers. Application gateways. Layer 6 Presentation Layer. Proxy servers. Encryption devices. Layer 7 Application Layer. Application load balancers. Web application firewalls. Proxy servers. While physical devices operate at specific OSI layers, it's essential to understand that real-world network devices may combine functions across multiple layers or interact with several OSI layers simultaneously.
Thank you for your attention. If you have any questions or needs further clarification, please feel free to comment.